Okay, so finally we're getting into the exciting part of this whole thing, which is integrating third-party libraries. The reason I say that is because until now we've learned a lot of things about CMake, like especially about the targets and like how you can specify sources and stuff. And we're going to use all that information to try and integrate third-party libraries, which means the libraries which were written by other people, like external developers. We're going to download the source files, either the source files or the precompiled binaries and the header files, and then we can use that in our engine. Just to like visually help you, I've written the same thing down. So the common two ways to integrate third-party libraries are, I've already discussed this, but just to like reiterate, use precompiled binaries and like link to them. So if you have access to like the binaries, like the static libraries or the dynamic libraries, you have libxyz.a or like libxyz.lib on Windows, libxyz.so, which is a dynamic library or a shaded library in Linux, or the same thing, .dll in Windows. So you find these libraries using find library command, and you use the header file provided, like lib.h or whatever header files they provide. You can just directly include them, and you can use that in your CML, and it will produce your app.exe or whatever, right? And then you can run that, right? So that was the first way. And the second way is to like build everything from source, which means you will have access to the source files, and you will have some headers, and you will have some source implementation files, the CPP files basically. And you will have the associated CMake list as well. So the people who provide this library, they have thought about all the CMake stuff, and they've written all the install instructions and all the build instructions in here as well. And you can just use this CMake list.txt in your build system by doing add subdirectory and by specifying the directory that contains this. And you can include lib.h or something like that in your application, in your header files or in your CPP files. And because you have access to the CML file contents, by doing this, you will have access to all the targets, and you will have access to all the things that you need to do with respect to CMake. And you can build everything together. Like at the end, it will produce all the libraries or the binaries required. And yeah, so this is how you can do it in two ways. So now we're gonna do this and see how it's done in a practical way, right? So now we're going to integrate something called GLFW. Many of you might already know this, but for those who don't know, GLFW is basically like a windowing library, which means whenever you open an application, it kind of runs in a window, right? So that window implementation itself is kind of like platform specific. So GLFW kind of provides an abstraction over all that, and it will give you like a friendly interface to work with windows, like creating window, destroying window, or like getting the events from the window and all the window stuff. You don't have to worry about the platform specific details because GLFW does that for you. And so you can just use the API that this provides, right? So we're going to try and integrate this, right? As with any third-party libraries, the first thing I do is like, I usually like go through the README file. Yeah, I mean, the README file usually contains all the information about how to compile, how to build and all that stuff. And like, because I'm using C++, lots of C++ libraries, they have CMake list file in them, and they usually think of all these things beforehand, and they'll provide the CML file. And yeah, so this is no different, right? So it has like there are some differences when it comes to like the implementations of that CML files in different libraries, obviously. But once you get used to like integrating more and more libraries, you will find very common patterns. And with practice, you can just like integrate libraries easier and easier than last time. Okay. So yeah, just wanted to tell you guys to like take the time to read the documentation, like the README file, especially the compilation info, which is what I'm going to do right now. Okay. Basically, it says that there are some precompiled binaries available for Windows and Mac OS, which means this is letting us do the first option that I showed you, like this one, precompiled binaries and link to them. And it also has like a compilation guide, which you can build from source, like build the whole thing from the source files and then include this subdirectory and do that. You can do both, right? Right, so if I take a look at, like, if I follow these links, I will eventually end up here, which has all the detailed instructions about all the stuff that I need to do. Like, for example, it says how to include a GLFW header file. I don't know if you guys can see the cursor. I will probably like know it when I'm editing it, if my recordings actually capture the cursor or not. But yeah, I hope it does. So including the GLFW header file, just read this. It just says like you have to like do this, include GLFW/GLFW3.h. Yeah, simple as that, and then link with the right libraries. With Visual C++, I'm not using this, so I don't care about this. This one, no. With CMake and GLFW source, right? Like if I have the source files, then I can click on this and I can read how to do this, right? So if you take a look at this, it's like you can read this, but it's pretty much doing the same thing, right? It's doing add subdirectory, which means that now you have access to the CML file that GLFW provides, right? Because you're providing the path and it has the CML file in there. And that CML file will have the target called GLFW, if you take a look at it. And then what they're doing is like linking my app to GLFW. Very simple, right? And then like it kind of depends on OpenGL, but it's not required in our case because I'm using Vulkan. And I'm going to show you how to use that with Vulkan later. But yeah, if you're using OpenGL, you can just like find the package OpenGL and do the OpenGL specific stuff. Again, I did not talk about this find package stuff yet, but I will because we're going to package our engine into a CMake package, and then we're going to use that. We're going to take a look at this. Don't worry. Like we're gonna dive into it much deeply. And at the end, it's going to become so much simpler. It's going to become so nice and elegant with packages. And you can also have like a really nice installed package system. Yeah, anyway, like I'll go on a tangent if I don't stop talking right now. So I'll stop talking and then, anyway, so that's it. This is how you can do it with source. Now let's take a look at this one, right? So right below it, it's saying CMake and install GLFW binaries, right? So let's take a look at that. It says find package, right? In our case, in the example that I showed you, where we're using find library, right? Like earlier in one of the previous sections, I used find library. In fact, I should still have that comment right here because I remember I commented it out, right? Yeah. See, take a look at this. We said find binary, but this, I told you this is a bad way, but the good way to do it is using find package. And so in find package, you don't have to do like target include directories and stuff. The package will already contain all the information about all that stuff. So we're gonna get into this, okay? So they're using find package to get GLFW, and then they're linking the target libraries like this, and that's it. Like this is about the OpenGL stuff again, and then that's it. That's how you can do, right? First of all, okay, to download this library, I can use something called git submodules, right? So if you don't know what git submodules are, think of it like using, just like how you can clone and download repositories just by using this command, like git clone and then using this thing. You can also like download inside a git repository. So what I've done here, let me close this. So what I've done here is I have converted this into a git repository, and I'll share the link later, but I've converted this into a git repository. So in here, you can add like a different folder called third party or submodules or whatever, call it whatever. And then you can add, so you can add this repository as a submodule. So the way you can do that is using the submodule commands. You can do it like I don't know if you can see the commands down here. Okay, I'll do it like the old fashioned way. I mean, I'll do it in a terminal instead of, because like I have something called git fugitive, I think, and it lets you do the git stuff right here in the neovim, in my editor's command line here, right at the bottom. If you notice, like if I do let's say I want to add submodule. Wait, I think the command is like submodule. I don't know. Let me do some help. Submodule help, and it says git submodule add, and then provide some options, and then it says repository, and then path, right? Oh, okay, it's actually very simple. Let me do it. Let me do it right away, right? Submodule add, and what was it? Like it said like add the URL. Was it the URL? Okay, let's try it. Add the URL, and then it says specify the path. I'm going to specify third party, and I'm going to give a name to it, right? Let me call it GLFW, right? Yeah, let's call it GLFW. Why not? Yeah, it's actually cloning all the project into that, right? All right, I think it's done. Okay, so it added a folder. It added a file called git modules. If I open this, it has the information about the submodule. And if I open this, it's created a folder called GLFW, and it has the repository here, right? So now, let's take a look at the CML file here, right? It's got all the stuff here, right? So basically, this is a project used by many people, and I believe this will work with like lots of different settings. So they have thought about everything, and they've added all that stuff, right? Yeah, so like if you specify glf install, right? So I bet this is a variable, right? This is a variable that they have provided, or like they haven't provided, and then, okay, so this is an option. We haven't gotten into options yet, but it's very simple. I'll talk about it. In fact, I'll just talk about it right now. It's very simple, similar to variables, but think of it like you're specifying some specialized options, and then you can set them to on or off. So if this is set, by default, this is set to on. If it's set to on, what they're saying is like if it's set to on, then they're saying install the directory GLFW into the destination, CMake install directory, and then all the files that match this pattern, install that into that. So it's basically the install command, right? So they're doing the install stuff here, right? But if I choose not to install this library, I can just turn this off. I can say GLFW install off, right? And similarly, we have all these other options as well. Okay, so all right, so it's the same exact thing. Okay, we can try and like compile this, I guess. So let's do that actually. Let's cd into that, cd into third party GLFW, and And where should we like build it? Let's build it inside, like right inside, right? Let's make a folder called build here, or sorry, let's make a folder called build right here. Okay, just to demonstrate like how you can build. We can say CMake build and build all that stuff into build. Oh, could not load cache. I think I have to actually make the build system first. Source is right here, and the build system should go into build. Okay. All right, so it's doing it, right? Okay. If you take a look at this, now it contains all the build stuff. See, like it looks exactly the same like we did, right? So yeah. And then now what we can do is like we can do that build step, actually build all the stuff. Finally, it's done. All right, so let's clear this and let's. What I'm gonna do is I'm gonna actually try and install this in the install folder. Let's see if that works. Okay, let's go ahead and install GLFW. I am just realizing that my install folder is missing. I might have deleted it for some reason. So I'm just gonna create it again. I just created the folder install. Okay, again, a fresh folder called install. All right, so okay, just to like take a step back and like look at what we're doing. So we got the coffee engine separate, like in a separate folder, and we got like the game app, which uses the coffee engine, right? It uses it. It can use it in two different forms, like this. Like it can either use the precompiled binaries, option 1, and then link to those directly, or it can like build everything. It can just like do an add subdirectory, and it can build everything from source, right? So similarly, we're doing the same thing with GLFW as well. So GLFW right now, it is a dependency, which means that our coffee engine depends on GLFW because coffee engine is going to be using GLFW, and in turn the game app is going to be using coffee, which depends on GLFW, right? So yeah, so that's what we're doing. So what I'm doing right now is I'm doing I'm doing the first option here. I'm going to use the precompiled binaries that I will get when I compile GLFW, and I'm going to use those binaries and link to my coffee engine, right? So I'm doing option number 1 now. All right, so okay, so we got GLFW here. We built it just now, and we're going to install it in the install folder, right? So I'm creating the folder outside because I want all of the installed stuff to be located in one single spot, right? Normally, if I didn't specify the prefix, it would install everything in the system folders, like I told you. So all of that stuff would be in the system folder, and so it'd be really hard for me to like show you guys what's happening when we try and install. So that's why I always keep creating like a custom install folder outside all the folders. And yeah, so that's the reason. If you were wondering why I'm creating install folder instead of installing everything in system folders, right? But yeah, anyway, so we have the install folder right here, and I'm going to do install, right? I'm going to install. Remember, like we are inside this now, right? I'm inside the GLFW folder, which is this. Okay, sorry guys, I had to close the window behind me because it started raining and it was super distracting. So anyway, we're back to this. We were just about to install GLFW. We'll specify the prefix, and okay, let's go back and see which folder we're in. We're currently in this folder, right? We're in the GLFW folder, and when we go back, so we're in this folder. So go back one folder and another folder. So we're outside, and then we can find this folder. Okay, so prefix, and then one folder up, and then install. Right. Okay, so it kind of installed GLFW, right? So I'm going to open it to show you what files are inside. So yeah, so if you open it, it's just created a folder called GLFW here, right? Just like how we got the coffee folder when we installed it, right? Similarly, it's got the GLFW here as well, and it's also got the library here. Okay, so it installed a library called GLFW3.a. Okay, so the static library here, right? And it installed some extra stuff here. This is actually about the packages. We're gonna get into this very soon. We're almost at the end here, so thank you for being patient. But so at the end, we're gonna kind of package all our like all the CMake stuff from our coffee application into coffee library into a CMake package. And when people want to include like coffee library into their applications, they can just do find package, and they will be able to find everything that has to do with like coffee engine, right? So we're gonna package into a CMake package. Okay, so that's what it is. Like someone from so GLFW guys, they also made GLFW a package, so we can find using find package, right? Yeah, so we're gonna get into this, don't worry. And the important thing to note here is that in the install folder, it created a folder called GLFW, and it installed the header files here, and it also installed the library, right? Like the binary static library. Okay. All right, so let's actually use GLFW, right? Let's use GLFW in our application. We're going to be using this in the coffee, right? I'm going to go to the header files, and I'm going to go to core, and I'm going to be using it in the window, right? Because that's where I want to use this, right? So let me actually go back to GLFW's documentation, and so if I go to documentation, and you can read this, but I'm just going to copy this very simple code. Basically what it's doing is like I'm including the GLFW header, which is here, right? This one. And I'm using GLFW to do something here, okay? I'll show you what it is in a moment. I'm just going to copy this. And actually, I'm going to paste it below this, right? So let me quickly walk you through. So it's going to create a handle called window, and then it's going to initiate the library. I don't want to return anything. Instead, what I'm going to do is I'm going to print an error that something happened. Error initting GLFW, right? So what it's saying is like if GLFW init function was not successful, then I'm saying like I'm printing an error, okay? Printing a helpful message, right? Ideally, you would want to throw an error, but anyway, I'm just showing you how you can do things. Okay, so it's creating a window. It's creating a window of width 640 pixels and height 480 pixels, and the window title is going to be Hello World. And don't worry about the other stuff. Basically, it's gonna all you need to know is it's going to give you the window handle in the window object. In the window thing right here, like the handle right here. So and then if the window did not work, it's going to terminate, and you can throw an error here or whatever, right? Throw error. Anyway, and then you're making the context current. This is a GLFW thing. Don't worry. So the important thing to note here is there's a while loop, and the condition is until somebody closes the window, just keep the loop running, which is exactly what we saw when I was like talking about how game engines work in general. Like, so this is the game loop phase. Remember I told you like there's an init phase, and then there's a game loop phase, and then there's a cleanup phase. So basically this is a very simple example of a game loop. And what it's doing inside the game loop is that it's using OpenGL to like do a clear color. It will paint with a particular color, and in this case, I think it paints I think dark bluish. It's been a while since I did OpenGL, so I'm actually not using OpenGL anyway. So I'm going to delete this. Our window is going to look black. The background is going to be black, and so but yeah, it's still gonna work. We don't need OpenGL to like paint anything inside it. Okay, it's gonna so here it's just doing something called swapping buffers. So every time the frame updates, you want to be able to show the fresh data on the screen and like discard the old data that you were seeing on the screen, and that's how your screen updates new stuff, right? So that's what we're doing here, and this is like kind of trying to poll events. It's trying to check if anybody has like given any input, like if somebody has pressed the key and then or if somebody has clicked the mouse button, it's going to listen for all those events in this function. And it's gonna, like, you can use them using callbacks later, right? So we're not gonna get into all that. I'm just showing you an example of how you can use GLFW. And okay, we're using this in the window class, window class and window.h file, which is a part of core. So I am going to go to the core CML file, right? So remember, we're in the engine right now, okay? We're in the engine, and I'm going to the core CML file, and in here, I want to link to GLFW, okay? So how do you do it? If you remember, I showed you like again, we're doing option number 1, right? We're using the precompiled binaries that we just got by installing GLFW, which are right here, right? This is the precompiled binary we got, and we're also using the header files. We're using these to link to our core target directly, right? So the core, this one specifically, the core target right here. We're trying to link this one to the core target, right? So how do you do that? I already showed you how you can do that. Remember when we were doing the game application? When we were trying to link the coffee application to the game application, we did something called find library, and then we're specifying all the include directories here, and then we're linking that here, right? So we can use a similar method to link core to GLFW, but instead of using find library, we can use something called find package, because if you look at the install folder again, what you notice is that GLFW has installed something called a package, like a CMake package. And what it means basically is that it bundles everything that you need, and it exports the targets for you, so you can use the targets directly, like in your application. So that's pretty handy. I don't expect you guys to understand straight away because I haven't gone into the package stuff yet. But basically, what we're going to do is instead of find library, we're going to use a command called find package to find the package. So let me close this. So I close the game application, and we're actually dealing with the coffee application now, right? So that was just to show you how we did it previously when we were linking the coffee library to the game application. We used add library, but now since we're dealing with like the core library, we want to link GLFW to the core library, right? So first thing we're going to do is we're going to use target link libraries to link core privately to GLFW, right? Okay, we did that, but where is GLFW? We don't know where GLFW is, right? So currently, like it will complain saying that it doesn't know where GLFW is if you try to compile this, right? So so how do we like let it find GLFW, right? The way you do it is by providing the install folder like we did last time, like using find library. But this time we're going to use find package because this is a package. GLFW has installed a package, exported a package. So we're going to use the package, okay? So the way you do it is using the find package, right? Find package. Again, like if you take a look at the instructions that they have given us to how to link with the library in this specific link, with CMake and install GLFW binaries, right? So if you take a look at that, if you take a look at this section, they're showing you how you can link the GLFW binaries to your application. You basically have to do, they're saying you have to do this, find package, GLFW 3.4 and required. They're just specifying the version number there, right? But it's basically like find command, right? Similar to find library, right? And then they're saying target link libraries, my app to GLFW, right? This is OpenGL stuff. We don't need it. We're not using any OpenGL stuff in the window, so we don't need this. We don't need to link OpenGL as well. So these two are the things that we need, right? So that's what they're recommending us. So that's what we're doing. Okay. So another thing that we have to do is we have to specify the path, right? Normally this would work out of the box because normally when CMake comes across this command find package, it's going to look for GLFW3 like libraries and like the associated package stuff in the system libraries, right? In the because I'm in Linux, it's going to look somewhere like user slash local slash lib folders or maybe like user slash lib folders. But right now what I've done to show you guys like how install works, basically I created install folder separately outside the outside all the other folders, right? So we're gonna have to specify that hey, this is the folder where all the install stuff is. So use this path to find whatever you're trying to find, right? So you do that by providing something like paths. Like if you remember last time, well, if you don't know that, you go to the CMake website, like you go to the CMake website, you go to the documentation again, and go to the reference documentation, and you go to the commands, and you search for find, right? Find underscore package, right? And then you can come down, and you can find like all the signatures and stuff. So we can specify the package name, and then version, and required or optional. So we did that. The way you can specify paths is like this, right? So paths, and then specify as many paths as you like, okay? So that's how you specify paths. I think if you specify one path, it's going to try and recursively search in all the libraries that it could be in, in all the directories that it could be in. For example, if it's doing it in Linux, it might know that there might be a folder called lib, and then inside lib there might be like something like CMake, and then inside that it might be there might be a folder called GLFW3, and then inside that there might be a file called glfw3config.cmake. So when you say find package, this is what it looks for, glfw3config.cmake, right? So the name of the library that you specify, right? The name of the library that you specify, and config.cmake. This is the file that it looks for, right? So I'm going to mention this path now. I'm going to say, okay, so we're currently in the core folder, right? In this folder. So if I have to go back manually like this, relatively, it's kind of hard. Usually, like you install stuff in system folders and not like custom folder. So you probably won't have to do like this all the time. But because I did it, I'm going to specify it manually, right? So what I'm going to do is like I'm going to use the CMake source directory command, CMake source directory path again, like the variable again, so that I can relatively add a path to that, right? So the way I can do that is like specify CMake source directory, right? The source directory, like again, to reiterate, it's it gives you the path, absolute path to wherever the root file is, the root CML file is, right? So which in this case is coffee, right? So we got this, and then we're gonna have to like go back one folder, and then we specify the install folder, right? So inside the install, it might find the library, and we can give it lib. Maybe it will find it. We'll see. Oh, sorry. I shouldn't specify this here. Okay, so we gave it the path, and we gave it find package, and we did it, right? So do you think it'll work? We can check it out. Like we can go back here. I'm gonna just clear these things. We can go back here, and then we can say CMake. Okay, I'm gonna have to come back because now we're gonna have to compile the coffee thing, the engine that we're doing. Okay, because remember, like we have linked the core to GLFW, so that's the extra thing we did, right? So we want to compile the coffee again. Okay, so the way we do it is just like how we did before, and we want it to go to build, but no, we have to like change folders first. We have to go to coffee. Okay, in the coffee folder we have to say CMake build, CMake generate the build system in the build folder, and the source files are right here. Okay, all right, so now let's build it. CMake build, everything in the build folder. Okay, it built the target core, and now what we can do is like we can try and install it, right? So CMake install everything in the build folder. I'm gonna give a prefix again. I want it to install outside the coffee folder and in the install folder, right? So it installed the engine now. Okay, so now if you take a look at this, it's created coffee folder right now. Okay, so there's a coffee folder, and there's an application.h, just like before, and yeah, GLFW is right there when we install the GLFW. This was from before, right? So in the lib, if you take a look at this, it's got core as well, right? Okay, so we did this, and now if we go back to the game application, let's try and build everything now, and let's try and see what we need to do in the game app to like link everything together, right? Okay, now let's try and use that and build the game application. But to just show you like what we're doing in the game application on the C++ side, we're calling the application get method here, like which is a singleton. And inside the get method, if I go to like application.cpp, inside the get method, I'm creating a window. I'm creating the window object, and inside the Windows constructor, I'm doing all the GLFW stuff, right? So technically, it should open a window as soon as I run the executable. It should open a window, right? I mean, it should print all the stuff that we ask it to print, but it should also open the window. Okay, so yeah, we linked GLFW to core library, and then we built the core library again. And now let's try and build the game application. Okay, so to do that, I'm going to open the game CML file, right? If you remember previously what we did, we linked core library to the game indirectly, right? So what we did, we used something called find library, right? And we got the location of the library, which is basically right here, right? Lib core is right here, and we got the location, and we're linking this in a weird way, like this, right? So I told you that this is a bad way of doing things, right? So the reason why I told you this is a bad way is because the good way, like according to me, to do it is using something called find package, right? And we're gonna get into like shortly, we're gonna get into packages where we'll make all our engine stuff into a CMake package. And so all you need to do, you don't need to do any of this, right? You don't need to do any of this. All you can do is you can just say find package, like coffee or something, right? Find the coffee package, and and make it like required, right? Required, and maybe like put a version number, just like how you did with GLFW just now. Just put the version number, and then you'll find the package. And so you can just directly link to the target. You can just do it like this, like, okay, a link to the coffee target, like we link to the coffee target core, right? To the core, and it will work, right? And so like if you also provide some other targets, you can also link to them as well, right? Like maybe graphics, right? It will link to the game graphics library. And so if you've seen this before, like if you've seen this sort of thing before, like you mention a namespace and then you mention the library, this is what it is. Like we're exporting the targets from our package, which means they can use the targets directly in this case, right? So this is an actual target. Like we exported the target, and then we're letting the consumer use the target. In this case, game is the consumer, and we're using the target directly, right? So now it has all the information about like the dependencies and like how it's linked to other libraries maybe, and all the target stuff that CMake needs to know about, it's all in there. Whereas like previously in this case, we're linking it to a location, right? Like technically this is just a location. This is just a location, and we're only giving it a location to where this is, and it's directly linking to the game executable, game target, and it's producing the executable that we care about. But this was a very simple scenario where luckily this one earlier, it did not depend on any other libraries, or it did not have any other target specific information that we needed to link against game. But in this case, the core library is dependent on GLFW. Because core is linking to GLFW, we need to use the target, right? So that's why we make packages, and that's why we export the targets, so that people can use the targets and they know all the information about the targets that are specified in the package, right? But unfortunately, we have to do it like in a dirty way, because we haven't discussed packages yet. I have to show you in a dirty way. But of course, like this one depends on GLFW, so you would have to find GLFW again. So we're gonna say find package GLFW3, just like we did before. In fact, I'm just gonna copy it from the previous CML file, right? From the core CML file, I'm gonna copy this, I'm gonna paste this, okay? So yeah, we found GLFW, I'm gonna quit this. Okay, so now that we specified the find package command, so it means that the game application CML file, it knows where to find all the GLFW stuff, right? So we're saying find package GLFW3, and we're specifying the path, right? In this case, let me double check if the path is correct. We're saying CML source file, and go back one directly and install. I think that's correct. So we're saying CML source, CMake source directory, which means the directory that contains the root CML file, which is the game app, and we're saying go back one directory and install. Okay, so the path is correct. And it's gonna find all the stuff that GLFW3 needs, which is the library and the header files that are associated with GLFW. All that information is packaged, and we're asking it to find the package. So now it has the locations, it has the information about GLFW3. And now let's take a look at link libraries, okay? So unfortunately here, we have to link GLFW again. Let me come back to this. Let me try and compile this and then show you that it does not work. And the reason it does not work is because, I will show you why it does not work. Let me first do the build. Source files are here, and build everything from the build folder. Right, build folders have been built. And now when I try to build it, pay attention to the error that it generates. Build. Okay, so it linked, when it was linking the executable game, it says it did not find, in the function core window, in the constructor, it did not find GLW in it. That's what it means. It says undefined reference to init. And here it says the same, undefined reference to GLW create window. It's not able to find GLW functions, right? When it tried to link the game application to this library, in this library it contains these functions, right? It contains these functions. GLW terminate, GLW window should close, and all that functions we used. It contains these functions, but it does not know that all the functions are right here. All the implementations are right here. Why? Because this is not a target. We're not specifying the target here. So we're just specifying the file location, right? So that's why I said this is a bad way to do it. We're manually asking it to find the library. We're manually specifying the directories. We're manually linking it to in a weird way, right? We're linking it in a weird way, which we were saying like game link to a location, right? Like in the previous case, it worked because it did not need to like find any other dependencies, or it did not have anything special associated to the target that it needed to like finish the linking, right? So in that case, we got lucky because it was a very simple linkage. It was a very simple thing. But now this one depends on GLFW, and it does not know it. Like CMake does not know that, because this is not a target, right? It does not have the target information. It does not have the information that core is linked to GLFW, right? So to do that, I'm gonna do it in a bad way again. Like I'm gonna say game link to hey game link to GLFW as well. So now game has access to all the GLFW functions. Like now this is a target, because why is this a target? Because this has the information from here. It finds the package. Package gives you the information about the targets as well, right? So now we can use the target here. And so now that the game is linked to this, it knows where to find all the GLFW functions. So when it looks for the stuff that's inside core, the core is kind of having these functions called. So the core is trying to call these functions, and it does not know where, it did not know where those functions were. They were in fact right here. And so when we link it, it will know that, oh, okay, they're all in here, right? So that's why it gave an error earlier, and now it should work, okay? So Again, if this is confusing, don't worry. Like when we don't usually do it like this. I'm just showing you the way to do it in a manual way, and we're gonna do find packages later. We're gonna say find package coffee, and then it will all make sense like in a very clear way. I had to show this to you so that you understand what's going on, so that when I talk about packages, it's gonna become much clearer. Okay, so thank you for your patience again, right? So I'm gonna go back and I'm gonna build it this time, and it worked. Okay, finally. And now let's quickly install it. Install build prefix install, right, it installed it, and now I'm going to go back to install. I'm going to go to bin, I'm going to say game. All right, so we have our window. This is running from GLFW. So this window is a GLFW window. I mean, I know that I specified like a much shorter window. I think like something like 650 pixels by 450 pixels or something like that. But because I'm using a window manager, like a library, sorry, like an application inside my Linux, which sort of like forces all the newly opened applications to open in like a split window view. That's why it's opening like this in a weird way, right? But this is the actual GLFW3 window, right? Okay, so we got the window, and then I'm going to close it, okay? Perfect. So now we're done with this one, right? We're done with precompiled binaries, and we link to it. And now let's look at how to build from source. This is going to be much easier because we can just directly add subdirectory and get the target, right? All right, to do it with the second method, which is like building from source, we don't have to like do all this crazy stuff. We can just do add subdirectory and like build it along with our coffee application. So first thing I'm going to do is I'm going to delete the build folder here. I'm going to go back to CML file, and I'm going to say add subdirectory. So if I take a look at the documentation and see how to do that, if you remember, like if I go back here, and this is the thing I'm looking for with CMake and GLFW source. So if I click that, it says add subdirectory and path to GLFW, right? So I'm just going to do that, add subdirectory, and I'm going to go back one path, which I'm right here. So I'm going to go back one directory, and I'm going to go back to install. Sorry, not install. I'm going to go to the source folder, right? The third-party GLFW folder. So I'm going to say third-party and GLFW, okay? So I can just do this, and I don't need to find package here because like I'm not looking for the binaries anymore. In fact, let me delete the install folder here, okay? Because earlier we were linking core to the pre-installed binaries, but now we're just compiling everything from source, okay? So I'm going to delete this install folder, and I'm going to delete the find package here in the core CML file. I'm still going to link libraries like this, core private GLFW. Why? Because now that I'm adding this as a subdirectory, this is an actual target, right? This is an actual target that is somewhere inside this CML file. Somewhere inside the CML file, they defined a package, right? Sorry, they defined a target known as GLFW, right? And maybe if you can't find it here, you might find it somewhere in here, like, okay? So they said add subdirectory. They have multiple add subdirectory commands, which means they have like, oh my God, look at this. Which means they have a CML file right here somewhere. Okay, so this is the CML file, and look, they have specified a target called GLFW right here, right? Right? So they specified all the sources the old-fashioned way, right? The C files right here, okay? So they did not do, like, I mean, they kind of did a mix of both, right? They did some, they specified some source files right here, and they also specified target sources right here. And the reason they did it is because like for Apple, they wanted to do it in a, like they wanted to specify other sources, and for Windows, they wanted to specify other sources and things like that, right? We're going to do that as well. We're going to do platform specific stuff as well when we're dealing with cross compilation. So because they have defined the target called GLFW here, and we're importing that CML file from here, right? From here, we're saying add subdirectory and third-party GLFW, right? Which we are like importing this CML file. And this CML file in turn contains another add subdirectory, and this file actually contains the target, right? So we can then use that, and so we can use that target right here, okay? So all we had to do was specify the CML file, the root CML file that was in the GLFW source folder, and now we can directly use the target, and we can link the target directly, and then it will work out of the box. We can just like do this, right? Okay, perfect. Now now that we specified this, we can directly like compile. I'm going to say CMake source, and I'm going to say CMake source is this, and I want you to build everything in build folder, right? Build. Okay, so now it's given us an error. It says add subdirectory not given a binary directory, but the source directory GLFW is not a subdirectory of coffee. Okay, so what it's saying is because I mentioned it like this, I'm saying add subdirectory, and I'm specifying a directory which is outside the current directory that we're working with, right? So when CMake is trying to do this, it's saying like, hey, you said that you're adding a subdirectory, but it's not actually a subdirectory. It's like something outside, right? Which means this is a common way to do, this is a common way to like integrate third-party libraries. So CML kind of is hinting at the fact that, hey, this subdirectory might be an external library, right? So this subdirectory, so when it goes to this command, this subdirectory, and it sees the source right here, this source, right? This one, okay, it did not complain because this is built by the same project. So we're the ones who made this whole thing, right? So we're the ones who made this file. And so it knows that this command is only getting that, is only getting what we made. But then in here, when we specified an external library, it's kind of understanding that, oh, this guy wants to integrate a third-party library, a library that is not created by ourselves, but someone else, right? So so now it's saying like, oh, okay, when I'm building stuff, I want to group all the other third-party stuff into a separate folder. And so please give me a name that I can use to like make the build files in, right? So if you didn't understand that, I will show you. It will make sense. It's very simple. It's basically I have to give it a name. I'll just call it third-party. I'm naming it third_party because I don't want you guys to confuse with third-party when it builds. So I'm going to show you what happens when it builds. Okay, I'm going to do this again. Okay, let's see what it did. I'm going to open the build folder and look at this. It created a folder called third-party and it created a folder called source, right? The source thing it knows already because this is an actual subdirectory, so it created it by itself. But because we're dealing with like an external third-party library sort of situation, it's creating everything in here, right? And this is going to be a problem later on because I haven't specified GLFW specific stuff here. So a better way to do this is that I'm going to delete this right here. And a better way to do this is like group everything into GLFW, right? Third-party / GLFW. So I want all the GLFW stuff, all the build stuff from GLFW to go into this folder, third_party / GLFW, okay? So when I do this, it's going to create a third-party folder, and inside that, it's going to create GLFW. So the reason I'm doing this is because in the future, if I add something else, like let's say Vulkan loader or Vulkan headers, right? So if I'm going to add this soon. So if I'm going to do this, I'm going to specify Vulkan loader, right? If I do it like this, it's going to install all of these. It's going to create another folder called Vulkan_loader, and it's going to put all the Vulkan stuff in here, right? It's going to put all the Vulkan stuff in here, okay? So that's why it's asking for like an external path, okay? All right, so we did this. We're gonna delete this, and we're gonna try and build this again, okay? Now remember, I deleted the install folder, so we don't have any precompiled libraries or anything like that, okay? It's gonna build for us, right? So I'm gonna do the build step now. I'm gonna say build, and I'm gonna say build folder, and look at that. It's kind of building GLFW stuff, and it will also build core as well, right? So it's built the GLFW stuff as well. So when I try and install this, CMake install build, and I want you to install, I'm going to give a prefix to a folder called install outside. I haven't created it. I did not know this, but I just realized that you don't need to like create the folder. CMake will create it for you if it doesn't exist. So I didn't know that. So I'm just going to specify the folder, even though it doesn't exist, even though I deleted it, it's going to create it by itself. Okay, I did this and it installed it, and it created a folder called install. And then in the include files, it automatically installed coffee and GLFW, right? And in the library as well, it installed the GLFW package. It installed my core library as well. Okay, so we did everything at once. Okay, so that was the second option that I told you about, like build it from source, right? So we had a CML file, and we did like an add subdirectory into the GLFW's source CML file, and it built everything together. Okay, so that's it. Now we have the libraries, and then we can go back to the game application now. And in the game application, we can use those installed binaries to run the application. But I mean, you could use the same exact thing that we did, where we manually like get all the libraries and get all the header files and link it manually to GLFW and get the game executable. But then we're not going to do it like this, okay? So what we did, just to like give you a better idea. So we did this one, right? So we built it from source. We got the GLFW build files, and then we kind of built our engine, Coffee, with GLFW source files, and we installed everything together, right? So it built both the things at the same time. Okay, just to show you what we did. So in this option, what we did, we got GLFW source files and coffee source files. So using both of these, we kind of built our binaries and then we installed it. And in the install, we got like our binaries like libcore.a and libglfw3.a and some package stuff, right? GLFW's package stuff that we saw, right? And we install all of them together just by adding subdirectory and like building them all of them at once, right? And then we can either use these installed files, or like when we want to link everything to the game, we can either use these and do the same thing again, like say like do the manual finding of libraries and then specifying the include directories and then linking it manually again. Instead of doing this, we can treat the whole thing, right? Like GLFW and then coffee and then the game app. We can like we can treat the whole thing as one big CMake setup, right? How can we do that? Well, I'll just have to comment this out and I'll have to do an add subdirectory here, right? So if you remember, like last time when we were dealing with like the engine project, we kind of did that, but I was just showing you how it all works. And so just like how we build GLFWs from source, we can also build engine from source, which means we don't, if we didn't want to install the libraries, we can just delete the install folder and we can just delete the coffee build files as well. And we can just delete the game app build files as well. Okay, we can now add some config in this, like add the subdirectory for the engine folder as well. And we can finally link the game directly to core, right? And we can add a subdirectory like this, like go back one folder and go to the coffee folder, right? And because this is an external library, right? This coffee is not a subdirectory of game app. Game app is not, people who made the game app did not make coffee, right? I mean, even though in this case, I'm the one who made both of these. But like what I mean is like for the game app, a coffee is an external library, right? It's an external library. So when I'm adding the subdirectory and like I'm specifying something outside the game app folder, right? So that's why I need to do something like third party. I need to specify a folder so it groups all the coffee stuff in the in one specific folder, like the folder name that I mentioned here. So third party, I'm gonna say coffee engine, right? Coffee dir or coffee engine or whatever, right? You can just name it whatever you want. I'm just gonna say coffee dir, okay? So it's gonna build all the coffee stuff in there. And we don't need to like find GLFW here because we're not, the game does not need to know about GLFW, because all the GLFW stuff that's needed, that's private to the core, and the core is already linking to the GLFW target, right? So because this is a CMake target, it has like now this CML file, it has all the information about like what core links to and what sources the core needs to build, right? So all that stuff, we're building everything together at once, right? So yeah, so now game will have everything that it needs to like get the core, and it also knows that core is dependent on GLFW, and it's gonna build everything together, okay? So I'm gonna save it, and I'm gonna go back. I'm gonna build, I don't need to build coffee. I can just build engine straight away, like the game straight away, right? So what I'm gonna say is like CMake source files are here, build folder should be in build, right? I'm gonna specify a folder called build here. Okay, I'll just make a folder, okay? I'm gonna put all the build stuff here. So when I say build, it's gonna build it. Oh, we got an error. It says CMake error at, oh, interesting. It says cannot, it says it's in the engine. It cannot find the file compile example game app, and then include coffee. Oh, okay. So this is interesting. Okay. All right. So we go back to this coffee CML file. We said engine include directory, the folder engine include directory. It should be CMake source directory and then /include, right? It works when we run the CMake commands in this folder, right? When we're building the engine separately, it worked because CMake source directory is now this, right? Because like we're running the commands here, this is the CMake source directory. But then because we are running the commands from here right now, because like we're building everything together at once, so I'm kind of like mentioning all the build source files about the engine inside this CML file, I need like whenever I specify CMake source _ directory, that's going to be this folder, right? This folder. right? So what we're going to do, what we have to do is we have to change this to CMake current folder instead, right? CMake current source directory, right? So like I told you earlier, the difference between source folder and the current folder is that CMake current source directory resolves to whatever CMake list file it's dealing with at the moment, right? So it's this one, right? Because it's reading this CML file, this will resolve to the current one, this one, okay? But when I say CMake source directory, like when I say CMake source directory, it's going to resolve to the directory that's the root CML, right? So I'm running the commands from here. So CMake source directory resolves to this folder, right? And so that's why it was kind of trying to resolve to the game app, right? So it says could not find source file, personal compile example game app. And then inside the game app, it was looking for the include files, right? Because earlier it was CMake source directory, and the CMake source directory in this case is game app now, okay? So that's why it's useful to know the difference between CMake current source directory and CMake source directory, all right? So now it should work. Now let's clear this. Did I save this? Let me save this and let me build it again. Okay, now it's worked, right? So now let's quickly build it. Build folder. Now it's building GLFW, and it built the core, it built our application, and it also built the game. Everything all together at once, right? I think that's a movie. So anyway, so it built everything that we needed, and now we can just install. Okay, CMake install, and then we can install everything from the build folder, and we can specify a prefix, and we can say install. Sorry, we can say outside install. So if the folder doesn't exist, it will create one for us and install it in that. Okay, and now it did install, right? So now let's go back to the install and see. There's all the stuff is right here, right? We built everything from just by taking all the sources, and we're building everything together. And we got the game here, we got the coffee include files here, GLW include files here, and we got the library as well, like library files as well. So we built everything together, right? So this is the second option that I was telling you about, like building everything from source, okay? And so now you know how to link libraries in two different ways, right? Linking from precompiled binaries, and then linking from building everything from source, and then linking the targets directory, right? So yeah, I hope you understand a lot about like how to like separate things into libraries, and like how to link libraries together, and like how targets work, and like how you can specify the properties like the sources and stuff like that. Now you understand everything, and the final thing that's left to do is to like understand about packages, right? We're gonna make this coffee engine into a package, so that when somebody installs coffee, they're not just gonna get like a raw library just like this, just a raw library and some header files. Instead of getting those raw files like that, we can also export something like how GLFW does, right? GLFW is a package, so it's exporting a package, and it's exporting the targets, and it's exporting some target like package files, and like it's giving some configs so we can find GLFW, all the stuff that's necessary from GLFW right away, right? And we can also do that. We can also make our engine a package, so that when we install it, our engine will also install some CMake files and some package config files, and and that's it. So that's the last step. Okay, we're gonna do that now.